Okay, so this is the beginning of part 2 of our measures of variation notes. So you should be on the back of your worksheet. You already finished the front, which looks like this. So you should be on the back. So this part of our notes, we're going to learn how to find the interquartile range. And as we saw from the first part of our notes, the interquartile range is the range of the middle half of data. Okay, so we have a dot plot here that shows the top speeds of 12 sports cars. Now, just a quick review on dot plots. Remember, each dot in the dot plot represents how many times that number occurs in the data. So if we have one dot over 220, that means 220 only occurs once. If we have two dots over 230, that means that 230 occurs twice in a data, and so on and so forth. Okay, so step 1, again, order from least to greatest. Cannot stress that enough. Order from least to greatest, always. Step 2, we need to identify the median of the data set, the median of the entire data set, and our first quartile, which is an abbreviation Q1, and our third quartile, which is Q3. Okay, so step 3, to find the interquartile range, we need to subtract the Q3, or third quartile, and our Q1, our first quartile. Okay, so first thing we got to do is we need to order our numbers from least to greatest. So these are our numbers in our data set, and this dot plot is going to show us how many times the number occurs in the data set. So I'm going to start from here because it is a lot of numbers. So we'll start with 220 because there's only one 220. Then we have 230, but there's two 230s because I know that because there's two dots. So 230, 240, and I have to write that twice because again there's two dots. Then 245. Now we have three dots, so we're going to have to write 250 three times. Okay, and then we have, looks like 260 twice. And then we have 270. So I ordered my data from least to greatest, so 220 to 270. Now, if we were just trying to find the range of this data, we would just have to subtract 270 from, or 220, I keep saying that backwards. We're going to have to subtract 220 from our greatest value number, which is 270. But we're trying to find the interquartile range of this data. So to find the interquartile range, first we got to find the median of this data. So let's go from outward in just to find the median. So we're going to go in, we're going to count out in, keep going, keep going, keep going until we find our median. And it looks like we have two numbers here, and you remember when we have two numbers we got to find the mean of those two numbers. So 245 plus 250, and then we have to divide it by 2. When we do all of that math, we're going to get 247 and a half, or 247.5. That's our median. Okay, now we need to find the first quartile, which is the median half of the upper half of the data, and then we also need to find the upper quartile, or the third quartile of the upper half of our data. So first let's find the first quartile. So to find the first quartile, all we got to do is find the median of the lower quartile, the lower half of our data. So 220 to 240. So let's find the median for that. So we work our way here. Oh, actually, no, we're supposed to start here from 245 to 220. So, okay, so let's rewind. So the reason why we are starting from here and not from here is because we had to add these two together and divide it by 2. So technically the data is in the middle here. So the median is 247.5. So technically the lower half of our median starts from down here. So 245 is still part of the lower half, and 250 is part of the upper half. Okay, so let's start from here, and we're gonna count our way out and go in. So again, because it's an even amount of numbers, we're left with 2 numbers. So 230 plus 240, and we gotta divide that by 2. So 230 plus 240 is, I hope you said 470 in your head, divided by 2, and that would equal 235. So that's our first quartile. Now we need to find our third quartile, or the upper quartile. So we start out and move in again. And if you like doing the cross-out method, you can also do that as well. So I'll do that for this set of data. So start out in, and then again, we're left with 2 numbers in the middle. So 250 plus 260, and we got to divide it by 2. And 250 plus 260, divide that by 2, you're going to get 200, well, hold on. 250 plus 260. Just want to make sure I got the math right on that. So 510 divided by 2. You're going to get 255. So that's our third quartile. Okay, so we figured out our first quartile, our median, and our third quartile. So now that we have all of those numbers prepared, we can subtract our third quartile, which is 255, and we can subtract our first quartile from it. So 255 minus 235 equals 20. So 20 is our interquartile range. And that's it. That's all we got to do to figure out the range. Just got to find our first quartile, our third quartile, and then subtract it, and then we get our interquartile range. So using our interquartile range, we can also use that to find the outliers of our data. So if you remember from, I think it was our first week, we were learning about our introduction to statistics. Outliers are the data that is much greater or much less than all the other numbers in our data. So using the IQR, we can find the outliers in our data. So for any value that is less than the first quartile minus 1.5 or 1.5 times the interquartile range would be considered an outlier. And then on the other side of the spectrum, we got any value less than, I'm just going to use the less than symbol, any value less than the third quartile plus 1.5 times the interquartile range is going to be an outlier. Okay? And just a quick reminder, again, when it comes to video notes, please feel free to pause and rewind whenever you feel confused, or whenever you just need to take a moment, or whenever you need to just pause it to write something down really quick. Please feel free to do that. That's why I'm making these video notes, so that you can rewind and you can pause it whenever you need to. Okay, so back to checking or using the interquartile range to find the outlier. So checking for outliers. So we're going to use the data that we have from this example, our sports cars, our top speeds of our 12 sports cars. So if we take the first quartile, which is 235, and we subtract that by 1.5 or 1.5 times our inner quartile range, which is 20. We're going to get 235 minus 1.5 times 20 is, pause this if you need to figure out the math, minus 30. 235 minus 30 is 205. So on the other side, we have 255, that's our third quartile, plus, not subtract, plus for this side, 1.5 times our inner quartile range, which is 20. Okay, so again, we have 255 plus 1.5 times 20 is 30. So 255 plus 30 equals 285. Okay, so based on these numbers, we need to see, is there any number that is less than 205, and is there any number greater than 285? If there's any number less than 205, then that would be considered an outlier. If there's any number that is greater or less than 285, it's also going to be an outlier. So, or outlier, or, hold on. Hold on, I've made a mistake. Any value that is greater, hold on, that's what it means. Any value that is greater than the third quartile plus 1.5 times the inner quartile range. Excuse me, pardon me, I'm so sorry. So it's any value that is greater than the third quartile plus 1.5 times the inner quartile range. So if there's any number that is greater than 285, it's going to be considered an outlier. So if we look at our data, is there any number that is less than 205? It doesn't seem like there is. Is there any number that is greater than 285? Doesn't seem like there is. So since there are no speeds less than 205 or greater than 285, there are no outliers in our data set. I apologize, I didn't put that up there. So there are no speeds that are less than 205 or any speeds that are greater than 285. So there's no outlier. So let me repeat that again so you don't copy down the mistake that I made. So any value that is greater than the third quartile plus 1.5 times the IQR is considered an outlier, not less than. That's the one over here. Okay, so any value less than the first quartile minus 1.5 times the inner quartile range is considered an outlier. Any value that is greater than the third quartile plus 1.5 times the inner quartile range is considered an outlier. Okay, so now that we've reviewed all of that, I want you to try this on your own. Find the range and the interquartile range of the following data: 5, 3, 6, 9, 2, 7, and 14. Okay, so you can write down your range here and the inner quartile range. Please find the inner quartile range of it. And I want you to check for outliers. If you need to remember how to check for outliers, check this part of the notes. Okay? If you need to remember how to find the range, go to part 1 of the first video. And the interquartile range is also here as well in this part of the notes. Okay? So I'll be walking around stamping to check for your try this problem, and if you do it correctly, I'll put a stamp down. Remember, once you are finished, go ahead and put the paper to the right hand corner of the desk so I can see it, so I can stamp it. All right?